Okay, imagine this. Picture an object just hurtling through our solar system, and not just fast, but really fast, like 61 kilometers per second relative to the sun.
That's booking it.
Exactly. But here's the thing. It's not just some random space rock. With every new look we get, it seems to be getting stranger, more puzzling, honestly. A little bit mind-bending.
Definitely raising some eyebrows.
Welcome to the deep dive. Today, we're really plunging into this enigma called 3I-ATLAS. It's a newly found interstellar object, and it has scientists totally buzzing.
And for good reason.
Yeah, for very compelling reasons. So we're going to try and unpack its weird behaviors, the surprising facts swirling around it, help you understand why it's grabbing so much attention, and, what it might all mean for how we think about visitors from other star systems. Think of this as your shortcut to getting up to speed on the weirdest thing currently passing through our cosmic neighborhood.
Good way to put it.
So let's set the scene a bit. Right now, 3I-ATLS is about, 2.56 astronomical units away from the sun?
Yep, 2.56 AU. That means it's already well inside Jupiter's orbit.
Already inside Jupiter's orbit. Wow. And it's on a fast track heading towards perihelion. That's its closest point to the sun, which happens in late October 2025.
That's the key time frame everyone's watching.
Right. And here's where it gets really interesting, I think. Its origin direction. It's coming from the Sagittarius constellation.
Which sounds familiar.
Exactly. The same area linked to that mysterious WOW signal, that super strong, unexplained radio burst from back in '77.
That is quite a coincidence. Definitely makes you pause.
It really does. It's got heads turning.
Yeah.
But the real urgency, I guess, is we need to keep a very close watch on this thing, especially when it makes that close approach to Mars. That's October 3rd, 2025.
You can bet the big telescopes will be locked onto it then.
Absolutely. So even just looking at its path, you were saying earlier, even from far away, it was a bit strange.
Yeah, that's right. What immediately stood out, even from those early distant observations, is that this object just signaled something different. Most interstellar visitors, they arrive from random points, random trajectories. Pretty chaotic, really.
The standard space stuff.
Right.
Uh-huh.
But 3I-ATLAS, its path had scientists scratching their heads almost from the get-go. It wasn't random at all.
Okay, so its trajectory was odd from the start, but I heard when scientists managed to get a closer look chemically, that's when things got really weird.
Yeah.
What did they find? What was so out of place in its chemical signature?
Precisely. That's when the real anomalies started popping up. Researchers used the Very Large Telescope, the VLT down in Chile, to study the gas cloud around 3I-ATLAS.
Okay.
And they found something profoundly unusual. See, normally when the sun heats up a space rock, a comet, whatever, we expect elements like iron and nickel to vaporize together. They kind of go hand in hand.
Was that?
Well, they're both forged in the same cosmic events. Think massive stars, supernovas. They usually get mixed together in cometary material. So naturally, you'd expect to see both in its spectral signature as it gets hotter.
Makes sense. Iron and nickel buddies.
Exactly. But here's the stark anomaly. The scientists detected clear nickel gas. Loads of it.
Yeah.
Yet, iron gas was completely missing from the cloud. Just gone.
No iron at all.
None detected. So it really begs the question, why is the nickel showing up all by itself? What kind of mechanism could possibly be releasing nickel selectively, but somehow keeping the iron locked away inside the object? It just doesn't align with our typical understanding of how cometary stuff behaves under solar radiation. It's like, I don't know, finding a cake recipe that lists sugar but somehow forgot the flour. It just doesn't work like that usually.
And it's a great analogy. Okay, so nickel without its buddy iron, that's already bizarre. But I gather the chemical weirdness didn't actually stop there. What else did the VLT pick up that just added to this puzzle?
You got it. It kept getting stranger. The telescope also detected cyanide in the gas plume around 3I-ATS.
Okay, but cyanide, isn't that sometimes found in comets?
It is, yeah. Cyanide itself isn't necessarily rare in comets. But what's truly striking here is the pattern of its release. The how and when.
Ah, okay, what was the pattern?
As 3I-ATS got closer to the sun, the amount of both the nickel and the cyanide just shot up incredibly steeply, like way, way faster than any normal comet ice sublimation model would predict.
Faster than just ice turning to gas.
Much faster. So the immediate takeaway, the kind of mind-bending part, is this. This isn't just a typical comet shedding gas as it warms up. The data is practically screaming different release mechanism, something beyond the usual story of sunlight hitting ice.
Wow.
And then, to add another peculiar layer to it all, scientists also found an unusually large amount of carbon dioxide coming off the object, CO2. significantly more than you typically expect from a comet its size or at its distance.
So it's like it's exhaling CO2, but way too much.
Exactly. Almost like it's breathing out,
Yeah.
but not in a way we understand for a natural comet.
Okay, this is getting really strange. Nickel without iron, this super steep rise in both nickel and cyanide, and then this excess CO2.
Right. And if you connect those dots, those intriguing pieces, you get Professor Avi Loeb at Harvard suggesting these strange signatures might not be natural at all.
You mean?
He proposes they could actually be indicators of something. Well, something to do with technology.
Technology. Like artificial.
That's the hypothesis.
Yeah.
Think about it. If you had, say, a spacecraft or some kind of engineered device, maybe it has parts built mainly from nickel but not iron. That's plausible in engineering, right?
I suppose so, yeah.
Then the sun's heat could indeed cause only nickel to be released into space.
Mm-hmm.
That would explain that specific spectral signature, the nickel without the iron.
Okay, that makes a kind of sense.
And what about that sharp surge in gas release? Well, modern engineering often uses specialized metallic coatings, or perhaps strong adhesives. Under intense solar heat, maybe those materials could break down and release nickel or cyanide gases in ways that natural comets just don't. That could explain the unusual spike.
Huh. Coatings or adhesives.
And it leads you to wonder, could the extra CO2 also fit some kind of industrial or engineered origin, maybe a byproduct of a process or outgassing from manufactured materials, rather than just typical comet behavior? Certainly doesn't fit the natural profile we're used to seeing.
That is, wow, that's a provocative idea. Suggesting technology based on just the gases coming off it. How are other scientists taking that? I imagine that challenges a lot of assumptions.
Oh, absolutely. It's definitely a hypothesis that sparks robust debate, let's say. Many scientists are naturally cautious, right? They want to prioritize conventional explanations first.
Look for the natural cause, however weird.
Exactly.
Yeah.
They're searching for any possible natural process, maybe something really rare we haven't seen before, that could account for these observations. But then you have others, like Loeb, spurred by these mounting anomalies, who feel it's crucial to consider all possibilities, especially after what happened with Oumuamua.
We'll get to Oumuamua later, yeah.
Right. The key thing is that these unusual signatures are forcing a deeper look. They're pushing the boundaries of what we thought we knew about these interstellar visitors.
So if Loeb's idea holds any water, we're talking about something that's literally outgassing like a machine, not like a natural icy body. It really does feel like something out of science fiction playing out right here.
It does have that feel.
And as if that wasn't enough to shake things up, the object's actual path, its trajectory through the solar system, adds another layer of, well, bizarre precision.
Yes, the path itself is another major clue.
Because it's not just the chemicals. 3I-ATLAS's actual path is remarkably precise. It's following a trajectory so rare it really stands out compared to typical space rocks, which, you'd expect them to come in at all sorts of random angles.
Total scattershot, usually.
Right. But 3I-ATA's, its path lies almost perfectly flat right in the same plane the planets orbit in, what we call the ecliptic.
Which is incredibly rare alignment for an interstellar object, just statistically improbable.
And it's not just a fluke, apparently. This specific angle, being on the ecliptic, would actually allow for a kind of flyby path that brings it closer to multiple planets.
Like a planned tour.
Exactly. It's almost like a carefully planned route. Very similar, in fact, to how NASA designed the Voyager missions, right? Those trajectories were meticulously mapped out to swing by several planets for study.
That comparison is definitely being made.
And just for peace of mind for everyone listening down here on Earth, there's a key detail. It's not coming anywhere near us. Earth will actually be on the complete opposite side of the sun when 3I-ATLAS makes its closest approach. So we're safely out of its way.
That's important context, yeah. But back to the path. The really striking observation here is what some scientists are suggesting. If 3I-ATLAS behaves unexpectedly, maybe subtly changes its route or trajectory when it gets closest to the sun.
Like a course correction.
Even a tiny one, yeah. That would strongly hint at some kind of unnatural mechanism at work. Propulsion, maybe?
Yeah.
So this unusual, highly precise path, this near-perfect alignment with the plane of the planets, it really raises the possibility that this isn't just a natural comet.
But something.
Something more akin to, say, a Voyager-type spacecraft, perhaps deliberately designed to look like a natural object, to blend in with the cosmic background noise.
Wow. A probe in disguise.
And another thing adding to this mystery. Scientists have also picked up signs that it might actually be producing its own light.
Generating its own light, not just reflecting sunlight.
That's the suggestion,
Oh.
which is completely unexpected for a comet-like body. They just don't do that. So the puzzle becomes, if the light we are seeing is just reflected sunlight,
Then it has to be huge, right?
absolutely enormous.
Yeah.
It would need to be bigger than Manhattan Island to reflect that much sunlight and appear as bright as it does.
Bigger than Manhattan.
Okay.
However, if it really is generating its own light somehow,
Then it could be much smaller.
exactly, its physical size could be much, much smaller, which frankly would be an even more profound implication about what this thing actually is.
Producing its own light? That just adds a whole new level of weirdness.
Yeah.
It's like a cosmic game of hide and seek, isn't it? Where the object seems to be trying to look like one thing, but all these clues keep pointing somewhere else entirely.
It certainly feels that way sometimes.
And this idea you mentioned of something slipping in quietly, it brings us to a really compelling hypothesis that tries to tie all these strange observations together. Right. This object, coming from that specific sort of mysterious region near Sagittarius, showing these strange chemical and light behaviors, following such a rare, precise path. It leads some scientists to suggest, well, maybe this is exactly how another civilization would explore our solar system.
How so?
They'd slip in quietly, while appearing to be just another natural visitor. This connects directly to an idea called the dark forest hypothesis.
The dark forest sounds ominous.
A little, yeah. The basic idea is that if advanced civilizations do exist out there, they might choose to explore silently, to effectively cloak themselves behind natural-looking disguises like comets or asteroids, and they'd carefully plan their movements to avoid drawing attention.
Why hide? Are they hostile?
Not necessarily hostile, no. It's more about risk assessment. They might understand the inherent dangers of being openly seen in a potentially dangerous universe. Maybe silence and observation is the safest strategy until you know more about your neighbors.
So like a stealth mission. Makes sense in a cosmic context, maybe?
Yeah.
And, this isn't actually our first time dealing with a really mysterious interstellar visitor, is it? We've been here before.
We have Oumuamua.
Oumuamua, yeah. Back in 2017, that was the first known interstellar object we ever detected. And it had its own list of really striking oddities.
It certainly did. That weird, elongated shape, for one.
Like a cigar or a pancake, depending on who you asked. And it showed that unexplained acceleration as it left our solar system. It sped up, but not in a way we could explain by outgassing.
And crucially, no visible tail. No coma, which just didn't fit the profile for comets or asteroids as we knew them.
Right. But here's the kicker. The lesson learned, maybe? Despite all those strange signs, most scientists, initially anyway, just dismissed it. They assumed it had to be natural.
The default assumption kicked in hard.
Yeah. And by the time people like Avi Loeb started seriously suggesting, hey, maybe this isn't natural, maybe it's artificial, or at least really unusual, it was basically too late.
It was already long gone, speeding out of range.
It had sped past Earth on its way out of the solar system. And that, looking back, feels like a huge missed opportunity. We were kind of caught flat-footed, maybe a bit too quick to stick to the conventional explanation.
A learning moment for sure.
Definitely. But now, here comes 3I-ATLAS, and we have a second chance. It's showing off its own unique set of unexplained behaviors, and this time, hopefully, we know better than to just ignore them or explain them away too quickly.
The scientific community is certainly mobilized this time.
Yeah, scientists are planning to observe it really closely, especially that key date, October 3rd, 2025, during its close flyby of Mars.
That's the big one.
NASA's Mars Reconnaissance Orbiter, MRO, it carries that powerful high-rise camera. It's expected to actually try and capture images of 3I-ATLAS.
Which would be incredible.
Now, the resolution, we should be clear, will be about 30 kilometers per pixel. So it's not going to be a sharp, detailed photo. It'll be more like seeing an entire city as just one blurry dot.
Still potentially very valuable data, though.
Absolutely. It could still give us vital information, especially for figuring out if it is producing its own light. And think about this. It could be the very first time an interstellar object is imaged from another planet.
A historic first, potentially.
Yeah, and other spacecraft might get a look, too. NASA's Psyche mission, maybe ESA's JUICE probe, they might be in the right place around late 2025 to also observe.
The more eyes, the better.
Exactly. So whether this thing turns out to be natural or something else, we've definitely learned from Oumuamua that these strange visitors deserve serious attention. We don't want to look back again and realize we let something potentially extraordinary slip away just because we weren't prepared to ask the big questions or maybe see beyond our existing assumptions.
Couldn't agree more. This is our chance to really apply those lessons.
Okay, so to quickly recap this deep dive, We've talked about 3I-ATLAS and its truly unique chemical signature, that missing iron, the dramatic superfast gas release. We talked about its remarkably precise trajectory right on the ecliptic,
Right.
and that really tantalizing possibility that it might even be generating its own light.
A whole suite of anomalies.
Yeah, all these peculiar behaviors are adding up, and they're prompting some of the biggest questions we can possibly ask about our place in the cosmos. And just remember that observation window, October 2025, especially around Mars, that's when we might get some of our most compelling clues, maybe even that blurry but potentially groundbreaking image.
So as you, our listener, reflect on this whole strange journey with 3I-ATLS, maybe consider this thought. If there is something beyond our current understanding quietly passing through our cosmic neighborhood right now,
Mm.
perhaps even deliberately designed to look natural, what does that really imply? What does it tell us about the sheer vastness and the potential inhabitants of the universe?
Yeah.
And maybe more importantly, how prepared are we, really? As a civilization, are we ready to truly understand what we might be seeing when the truly unexpected finally arrives at our doorstep? This deep dive into 3I-ATLS, it isn't just about one weird object. It's really about pushing the boundaries of our own curiosity, challenging our assumptions about what's possible out there, and maybe, just maybe, finding something extraordinary hidden in plain sight.
Okay, imagine this. Picture